One of the things that we need is a good analysis tool to make sure our programs are going to work, make sure our programs are efficient, and make sure that we can add very easily enhancements to our code. To do this, we're going to be using simplified Nasse-Schneidman diagrams, and these can be used for C, C++, C#, F#, Java, any kind of structured programming environment. It's very handy to use. And what you find is that if you want to think inside the box, that's how we start off with our very simplified Nasse-Schneidman diagrams, because these brace brackets that you've got in your main are really, in any brace brackets, are basically corners of a box, the left corner of the box. Now if we take a look down here, let's take a look at a typical program. It's a very simple program, and this is the structure diagram for it. Again, these corners here, these brace brackets, are the corners of the box here. And things like includes and declarations and formatting of print statements don't really come into a structure diagram. It's really just what is our logic flow. So the first statement, A equals 5, is really A gets the value 5, B gets the value 7, C gets A plus B, and the screen gets A, B, and C. That's basically what this is doing. It doesn't take into account, again, formatting, variable declarations, or includes. Now this one, again, includes, variable declarations don't come into it, but in this case we're going to be scanning a value, bringing in a value from an external device, which in this case our keyboard. Later when we start working with file I/O, same sort of thing. So this little parallelogram here indicates input coming from a device. Could be a file, could be in this case our keyboard. So variable B is being brought in, and then we're going to take a look at A equals B times B, and the screen again gets some stuff here. And the get ch we could put in here, but the get ch or get char that we might use in here is just to hold the screen open so we can see the output before the screen closes. So it's sort of an option to put in here. Now let's take a look here, and this is a very simple program. It says if A is less than B, do this. If A equals 7, do this. This is an if statement followed by another if statement. Let's see what that means in terms of our Nasse-Schneidman diagram here. Again, this brace bracket is this upper corner, the bottom one is here. And notice we've got if and brace brackets here. So this is our if A is less than B. And if you remember some of the things that they have on TV, they have the Price is Right, and there was something called Plinko, where it comes down here, hits a little metal tab, and it either goes this way or it goes this way. And this is basically how our logic flows. If A is less than B, plink, it goes in and does this. If it's not, it just continues on. And the if statement says if it's true, we do something, and if it's not true, we do nothing and just continue on to the next thing. So we can see here again, here's our brackets, and here's the corners of the box here and here. Same thing down here. So if this is true, it's going to do yes. If it's not true, it does nothing. And then it goes on to the next statement. If this is true, it does this. If not, it does nothing. And if you take a look at an if statement, you can see one if statement has two possible outcomes, yes or no. But if you put an if statement with another if statement, you got 4 and yes, yes and no, no and yes, no and no. So there's 4 possible outcomes. If you have 3 if statements, you have 8 possible outcomes. 4 if statements, you have 16, and so on. So it goes up very quickly, as opposed to an if-else kind of statement that we have here. Now if we take a look at this if statement here, everything from here to here is one statement, not a series of separate statements, but one statement. And the way it works here again is A is 5, B is 7, if A is less than B. Now we notice these brackets here are the corners of this box, this if, the corners of this box, and finally this else part, which is a default case, the corners of this box. Now with this, if we go plink, if this is true, that's it, and it falls through. If this isn't true, then if this is true, it plinks and goes here, plink, plink, no for the default case here. So there's only one possible outcome from an if-else statement, and it's very easy to see in this diagram. A while loop, very simple structure. We put a bracket here and bracket here, and that's again the corners of this box. So while A is less than or equal to 7. Now before we do anything with the while, we put an A, we have to have some sort of assignment here so we can do the checking here, and this is the bracket. It's very easy to code this up. Brackets again are the corners of a box. Now if we look at a for statement, any for statement can be rewritten into a while, but not all while statements can be rewritten into a for. So we take a look again at the brackets. That's the corner of the box for a equals 4, a less than or equals 7, a plus plus. It's going to do what's in here. So the diagrams are not that difficult to understand, but the one that's a little bit more interesting is our do while. And it's got a kind of nice structure here. A gets 4, do, and here's our brackets again, bracket, bracket, while a is less than or equal to 7. So it's going to continually do this and this while a is 7, and it's going to check at the bottom, not at the top, so it's always going to do this at least once. This is how we specify a function call. We put an extra bar here just to indicate that that's a function. These vertical lines here indicate that the structure diagram for this is somewhere else.